Well, hello, my viewers. My name is Robert Gully, and the central theme and experimentation of this video will be centered around that of chromatography. Now, chromatography is a separation of two or more substances using that of a solvent and or vapor. Now, there are several different types of chromatography, but for this chromatography, we'll be separating our substances using a liquid solvent, or more specifically, water. You can also use isopropyl alcohol for this. However, due to the vapors that may arise from that, we would have to do that outside. But since we're doing it inside, we'll stick with water, just for our safety. Now, for materials used in this experiment, you will need markers, several different pens, a pencil, some coffee filters, some scissors, a ruler, some tape, several plastic cups, and again, water. Now, one of the first things you want to do is you want to cut your coffee filter into a shape similar like this. Now, I've already cut a piece like this it can already be used. But for any of you who may need help, you want to flatten out your coffee filter like that, and take your scissors and cut a piece on both, cut half the size on both sides, enough to where you leave a sort of shape like this on the middle. You all see that? It'll be a bit hard to see because it's both white, but if you see that. Now, next what we'll do is we'll use one of our pins, wrap it around the pin, but you only want to wrap it around enough to where the coffee filter can sit somewhat like this, as you can see. Not touching the bottom too much, but enough to just kind of touch the bottom. Now, what you do next is you take a strip of tape, and what you want to do is, now you can either tape a long piece to go across one time, or tape two like I'm going to do, but you take your strip, put on one side of the coffee filter, and put it on another side of the coffee filter where the pin is. So this way, it doesn't move. Now, you repeat this four times in total, this being the one time. And just for the sake of time, we'll skip ahead of the video so that I can be able to move on with the experiment.
A few minutes later.
And now that we've gotten that process out of the way, as you can see, with each of the four cut pieces of coffee filters, it's enough to touch the bottom, but it's not enough to where it's just covering it. Now, next thing you want to do is that you want to measure how far above from the bottom we want to put our starting point. What seems to be a good point is around that of, say, 3/4 to an inch with the coffee filter. And also, for anyone that may have had trouble with cutting it before, I recommend a length of around almost 1.5 inches. That way it's not only a good size, but you also have a good measurement in case you may not cut that well. So what we want to do is we want to measure it about almost an inch above, and then you do this in pencil. So this way it's not affected with the solvent when we put it inside this next phase of the experiment. You're more than welcome to skip ahead because we will be repeating this with each of the other coffee filters.
12 seconds later.
Now that we've gotten that out of the way, you want to choose two colors from each of your markers and pens. For me, myself, I've chosen a red and a blue marker, and I chose a purple, and an orange pen. Now, what you want to do is that you will now cover the line that you made with the pencil for each of your colors. Again, you're more than willing to skip ahead because we'll be repeating this process with each of the colors. You also want to make sure it's strongly put on there so that it can be able to be separated. You see, these will be, the goal is to separate each of the mixtures using the solvent.
12 seconds later.
Now that we've gotten that out of the way, as I said before, since we made these about an inch above, you want to make your water about probably around half an inch, or really enough to cover the bottom. So, actually, a better method, which be, see here, that's with the orange. Okay. Enough to cover the bottom. 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 Let's add a little bit more here and here. Now remember, you only want enough so it can touch your color filter because you don't want it to touch your solvent. All right. And now I'll move these closer to the screen so that you all can see the magic as well. Now, the more boring aspect of this experiment will be that it takes time for the solvent to rise. Also, another tidbit is that we don't want it to reach all the way to the top. We only want it to reach close to the top. Once it reaches close to the top, that's when we'll be able to pull out each one. Well, I'll see you all in probably, no, maybe, hopefully not too long.
A few minutes later.
Now, as you can see, although it's not too visible, fortunately with purple, the blue marker, the red marker, and the orange pen have started making headway. Now, you're probably wondering, how is this occurring? Well, as the copy filter absorbs the water, it carries the mixture with it. Now, I want you to imagine you're at a water park and you're at a water attraction. Now, imagine you're on top of a floating. Now, let's say you're on something that's like dry land. This is where we were before, which was called the stationary phase. Now, what's going on now is called the mobile phase, i.e., it's the solvent moving through the copy filter mobily. Now, I want you to imagine that while you're sitting there, a gush of water comes through. Now, what's more likely to happen with you and your floating? You guess it? It's being carried by the water. Similar to this, the mixture, or in this case the dye from the pens and markers, is being carried by the solvent through the copy filter. Now, why this is happening is because that during the stationary phase, if the substance reacts strongly, i.e., if, for example, let's say you're playing roughhousing with somebody and you put a real strong base to the ground, you gripped your feet to the ground. If they were to push you, you wouldn't move very far, would you? That is what's considered a strong reaction, where it has a strong hold during its stationary phase. Now, what's happening now with the mobile phase is where if the substance does not have such a strong hold, i.e. you don't have such a strong hold on the ground. When your friend comes and pushes you, what happens? You get knocked over. Now imagine that, but you keep getting pushed over, you keep getting pushed down. You can also imagine that with my water attraction experiment example, where the water is pushing you. Let's say your floaty is really heavy and has a strong hold to the ground. Not going to move very far, is it? Now, if it's not very heavy and it's actually doing what it's supposed to, which is supposed to move with the water, it'll move very easily more than others would. And now that I've explained that tidbit, I'll go back to, well, waiting for our substances to reach the top of the carbon filter paper.
One eternity later.
So, as you can tell, with the blue marker, we can see there are bits of purple following the trail of blue. Now with this, we can tell the separation of dyes. It seems though there was purple dye mixed in with the creation of the blue dye. As for the red dye, it doesn't seem like as much was separated by the looks of it. At best, you could argue that it's just a dark shade of red separated into, well, lighter shades of red. And although it may not be very visible on camera, you might be able to somewhat see it. The orange pen seemed to separate into somewhat of a, seems to be yellow dye. Yes, it seems to be a yellow dye. And finally, with the purple pen, it seems as though it seemed to somewhat separate into, well, just a lighter shade of purple. So, I think we could conclude this experiment as being finished. Now, what did we learn today? We learned how the dyes separated from the solvent carrying them in the mobile phase. We learned why they separate, i.e. The solvent carrying the substance that doesn't have as much of a strong hold more quickly along, i.e. the blue marker, and you can say some of the red marker, and even the orange pen seemed to come along nicely as well, even though it stopped at a point. And the solvent seems to have outlasted it. As for purple, it somewhat seems to separate, but not by too much. And although this video can seem long, and trust me, it was even longer in real time when you have to wait for the carbon filter to absorb the solvent. And also for anyone that might have been or missed it, the solvent is the water, or really the solvent is the whatever liquid or vapor gas you use to try and separate the dyes. So that is our video on chromatography, and I hope you all learned something new today.